Okay, so this project here, we're going to take a potentiometer, which is down here. It's a variable resistor, and it's got the knob on it. A lot of you will recognize it like a volume knob on a radio. And we're going to patch that into your Arduino. I have it hooked in through the A0 pin, which is an analog reading pin. And then one side of it goes to positive, one side of it goes to ground, and then the pin in the middle goes to A0. And then I did a hookup down here of your LCD. I included a schematic and also a wiring diagram. It looks a little chaotic on the wiring diagram, but I think I got all the wires in there in the right spot. I chose an easy way to wire them because, you know, we have digital pins here like 4 through 7. So I just plugged in D4 to D4 up on the Arduino, and D5 to D5, and D6 to D6, just to make it easier. And then the other two pins, I think the RS and the E value, I ran up to those as well. What I'm going to have you look at for that is the code, so you can kind of see how that comes into play. And let me see if I can pull that up here. Oops. Okay. Come down here, Unit 2. Won't worry about the challenges yet until we get through this. Be sure you pay particular attention to the wiring. I didn't put as many wiring instructions in here. We did talk about reading an analog pin and what we get from that, and I also introduced you to the map function. Coincidentally, I put that Arduino reference in here, so if you click that, that'll pull up the reference page. That's also locked on the top of our classroom, and that will give you some ideas of what it does, but I'm going to explain it real briefly. So I got a wiring diagram, and I hooked it in as if this were a nano and a breadboard situation, so you can kind of see where the wires are coming. And yeah, it's hard to read that. One thing I want you to get more familiar with is try and work through a schematic diagram. This is an electrical diagram that your electrical engineers work with, and it shows how to hook up the parts. These are variable resistors. This variable resistor and this resistor here are built into your Arduino kit, so you don't need those. But we have to put them in the schematic just so we know that they exist. Plus, if you're building this with loose parts, you'll want to put them in there. That's for the contrast knob, and this is the resistor for your LED, your backlight on your LCD display. So I think the wiring is pretty straightforward. If you look at the connections, I do want to show you kind of where this comes into play in the code. We're going to be using our liquid crystal again. So this line here tells how it's wired to. Now in the previous lesson we put variables in there and we assigned the variables numbers. Usually you don't do it that way because these don't change. Once they're hardwired, you don't just need to change which pin it's on, and it's only in one case, in one place in the code. So I put a comment under here that shows which wires are going to where. I like to put this little line of code in there because it's just a reminder, and I can look at the code and go, yeah, how was this wired? The RS goes to 2. The E or the EN pin goes to 3. D4 goes to your Arduino pin 4. D5 to 5, 6 to 6, 7 to 7. It just made the hookup a little bit easier in my opinion. And the one thing we're going to do in here is we added in a new statement that you've not seen before. And this is the serial begin, and this is a speed in which you're transmitting to it. What it's going to do is it's telling the Arduino to send data back to the computer, and you're going to view it on the serial port. And I'll get to that in just a second. This is the speed. You want to make sure your speed is set correctly on your computer, and I'll pull up the Arduino software if I can get it to display here and show you how that works. And this should look kind of familiar to you. LCD begin, you notice this is in the setup operation, so it displays it once. And it's going to put a volume level on the top. And let me show you the operation of this real quick. When we get to the final project, you're going to have a knob over here, and when you turn it, you notice the numbers on the LCD display. I have one called pot for potentiometer, and you'll notice as I turn this, the numbers change quite rapidly. And then there's another one which I'm calling V for volume, and it will not change as quickly. The range of this potentiometer will give you a much larger range of numbers. It goes from 0 to 1023. 1023 is your 8 bits in binary. That's a fairly common number in coding and programming. But this knob, and then we're going to translate that and do a little formula on it and get it to relate to a volume setting over here. Now, I told it to go up to number 8. And you're going to see in the code where you can change that. I know most of the car radios today, when you see those, they go up to 40. I don't know who picked 40. Back in my days, they always did 0 to 100 as a percentage.
0 to 60.
0 to 60? Yeah, I don't know. Mine goes to 40. I'm like, you know, maybe that's a decibel rating or something. I'm not sure why they chose those numbers. But we're going to look at how the data that we get out of here is read by the potentiometer number, and it varies as I turn the knob. And then we're going to relate that number, or do a connection between the number here and the number that's displaying for a volume level. So let me pull this up again and talk about the code for a second. This line here that says serial begin, it's only going to come and play down at the very bottom. And what I do is I worked with the LCD. I told it where to begin. I told it that it was a 16 by 2, so it tells us the number of columns and rows. We clear it. We set the cursor to the 0, 0 position, and we told it to print volume level on the LCD display. That was in the setup. Then in the loop, we do some creative stuff here. We set the cursor at 0, 1. Well, first of all, we read a potentiometer value. I put pot value, analog read, so it's getting data from that pin. It's reading it. And the potentiometer pin is a number up there, which I think I put A0. And then we're going to read it. We're going to print some text. And this is my little magic line in here. It's called a map function. If you go back to that Arduino reference, this helps you make comparisons. It's a linear relationship between two values. And what it does, it says I'm going to calculate my volume. I'm going to define a variable called volume. And I'm going to map it, or I'm going to direct it or correlate it to my potentiometer value. Goes from 0 to 1023. And I'm going to make that match 0 to 8. If you wanted your volume to go up to 40 or 50, or you would just change that number. So it's taking these values and it's making a match up to here. It's kind of like a conversion. You know, you could easily do this between like Celsius and Fahrenheit and come up with a real easy formula, and you don't have to worry about all the weird conversions when you map a value from one to the other. If you were doing like Celsius to Fahrenheit, you'd put like 0 to 100, and then you'd put 32 to 212, and it would make the connection or the change between those two values all the way along the scale. So then we printed some spaces, and this is to clear out the numbers, and we printed some numbers. Keep in mind, if you're printing text, it will be enclosed by quotes. Okay, and you see that up here on the volume level. It's enclosed in quotes. It's printing actual text. If you're printing a variable, which I did down here, there's no text. You just insert your variable in the parentheses. And these are the locations. Once again, it goes by column. Column 5, row 1, or column 5, row 0. Row 0 is the top. Column 0 is the top left. So it starts at 0. It doesn't count at 1. And then we did a little value in here, and this is kind of your new code. It's another way of displaying data. It's telling it to print to the serial port. I told it to print pot, and then a number, and then volume, and then another number, and I followed this one here by print ln. that tells it to print a new line when it's done. So it kind of hits the carriage return afterwards and starts a new line. So what will happen, let's see if I can pull up my software here. And let me see if I can get this to show my Arduino. Okay. It is not doing that. Oh, let's see if it's here. For some reason. Okay. I'm not able to get my Arduino software to pull up. Let me try one more thing here. I don't know why I fight this software so much. Must be the thing to do. Add a window. Okay, that'll work. Can you guys see the Arduino window?
Yeah, I see it.
Okay. Okay. I don't know why this stuff seems like every time I reboot my computer it does something weird. So this has got the blink sketch. Let me see if I can pull up real quickly what I was working on before. Open recent, volume level, potentiometer. Okay. Now you guys are still looking at the blank sketch. Okay, let me check something here. Okay. Pardon my technical problems. Let me do this. Control C. I'm going to paste it into here. Okay, this is the code that is on there. And when you send this code over, it should operate the program, but what I want to show you is this little button over here. This will open up what's called a serial monitor, and it will receive communication from your Arduino. If you're looking at your Arduino at this point, it will actually be flashing little 1 and 2 lights, the 0 and 1 lights, which are for receive and transmit. And the same data that it's displaying on the LCD screen, it will be displaying on your computer screen. So you can actually feed data back in. And that is what, I don't know if you guys can see that. I don't know if that's popping up. Are you seeing the COM port display? I don't think you are. Let me try something here. Let me add a window. I don't know why this stuff is so challenging for me. There. Okay. Now we got the window. Sorry, when you open up the little arrow button on the top, and you click this little arrow or the serial monitor, it will pop up this window. And this is another way that we can display data from your Arduino. Now the cool thing is it really doesn't take anything to wire this up. It doesn't take anything to really get it to work. You just enable the serial port with that one command with the baud rate. By the way, if you're getting gibberish and you're getting weird stuff, you want to look down here where it says baud rate and change that number. which I lost my serial monitor. I can get it to come back. And we know where it went. Okay, let me move this. So yeah, it has a baud rate down in the bottom. You know that 9600 number that it had right here in serial begin, 9600? That has to match this rate. If it goes too fast, you're going to get gibberish. If it's too slow, you're going to get gibberish. For some reason, the standard setting is 9600. I doubt you're going to max that out any point in time. So you can go with that. Are the mouse pointers going crazy on your screen? Okay, I'm showing all sorts of bizarre things taking place. But what this will do is it's going to give us two different outputs for your screen. It's going to give you the LCD display and also this serial monitor as a way of displaying data. And you just simply, in your code, you tell it what you want it to display. So what's coming out in that serial monitor is code from right down in here. See where the LCD print and moves cursors. These bottom four little lines are printing the pot value and the volume level that I'm using, and it's all in these bottom four little lines of code. And then there's a delay, and TIM is for time. That's defined up in your variables before. I think it's set for 250 milliseconds. Every quarter of a second it updates your screen. If you don't put that delay in there at all, the numbers will just scroll really, really fast, and they're hard to see what's going on. But this is a secondary way for you to not only read data and get it to do something, but also to display the data. Because sometimes you have to know what the computer is seeing or what lines it's getting to. So you can put in a little serial print, or if you hook up the LCD display, you can hook those up and know exactly what it's doing. So with that in mind, let's come back to here. Make sure you read through all of this stuff on here. There's a lot of information on the site. Trying to go through a lot of efforts to put some stuff in there to inform you of what's going on and kind of the syntax and not making it too dry. But then experiment with it a little bit. What I want you to do on here for the challenges are this. Oops, go back one more. We've got our 3 challenges or missions to complete once we get this wired up and working. Pay real close attention to the wiring. This is going to be different. So edit the code to display a volume range from 1 to 40. I picked 40 because it seems most car radios go to 40. Maybe it's 40 decibels. I'm not sure why. I was told in class here that somebody goes up to 60. So where in the code can you change that number so that when you turn the knob, that number goes from 0 or 1 to 40 instead of 1 to 8. I think I hard-coded in there. And the challenge, this one is going to combine what we did before. Remember blinking LED, that first project that we did? And we changed the time, the delay value. Well, now we want to see if we can read the potentiometer. We can do an analog read, and you're going to get a number between 1 and 24, and we want to see if we can use that to change how long the delay is for blinking your LED. So you're going to read some data from your potentiometer, and as you turn it, the light will blink faster or slower. And then the last one will be combining everything. Display the delay time in the LCD monitor from mission 2. So this mission up here, we want to get that data, the display time, to show up in the monitor on your computer, the serial monitor. And then here's the challenge. This one I won't give you too many clues. I'll let you work with it for a little bit. Can you display the time delay in tenths of a second? For example, the delay is typically 1,000 or 2,000 for 2 seconds. So can you display it as 1.5 seconds or 0.7 seconds as your delay, something that makes more sense than milliseconds? I'm going to let you Google a little bit and research that. You may need to try Google something like Arduino displaying decimals. That might help you a little bit. And I'll also point you to the very top of this page, which is your big Arduino reference. And when it pulls up this page, it goes through basically everything we're doing. You'll notice a few things popping up in here that we're working with. For example, the map function right here popped in. That's the one that we're working with today to do numbers, and it will give you some examples. We're also doing analog read, which is how we're getting the value off of the potentiometer, and it tells you a little bit about it, how it works. And it gives you technical aspects of the different boards and whatever, but we're getting some of those things in there, and this reference may also help you with displaying decimals, because it's going to get back to some of the technical documents on the Arduino, and well, how do we do that in code? We don't want to say it's delayed 300 milliseconds, we want to say it's 3/10 of a second. So how can we display those values as we turn the knob? So that's what I got for this lesson. I'm going to turn you loose and let you work on the wiring. The wiring is going to be a little bit more challenging than before because I'm not giving as much direct instructions, and you're going to have to kind of look at the code to figure out how it's wired. Also, the one thing we did not mention in the code is, let me see if I can pull it up here. The several wires are not, oops, I think I lost my page. Several of the wires are not listed directly, everything's closing out now, directly in the wiring. For example, you have the ground wires and the positive wires on your Arduino, and yeah, I closed it out. They're not listed in the code, but they're common wires that need to be in place. Let me see if I can get this back here. I need to find a better way to make videos. Got too many windows open. Got my faster computer, but now I can't juggle everything. It's not showing what it should be showing. Okay, I can't get my screen to come back up. Yeah, can't get anything to come up now. So look at your wiring real close in the picture that's supplied on the Tinkercode site. Make sure you get the ground wires that loop together and the positive wires, otherwise it's not going to light up and work correctly. But all the data lines are also shown. So, and those are kind of explained in the code, but the ground wires and things are not. So I'll help you on the coding if you need help, and I'll turn you loose and let you try and build this thing.